everyone, this is Grace Scannell with a brief presentation on the development of ovarian hyperandrogenism and polycystic ovarian syndrome. So just to give you a brief preview, hyperandrogenism is the presence of too many androgens within the system of any person. In this case, we're going to focus on the presence of hyperandrogenism in women, which results in this sort of phenotype, someone with hirsutism, which means facial hair, which is unusual in a woman, right? So this happens when they have too many androgens in their system, and it causes the development of hair in the same way that that would appear in a man. They'll also be prone to acne and to excess fat development, especially around their upper arms and abdomen. So one of the things that I think people get a little caught up on in polycystic ovarian syndrome is this idea of having multiple follicles developing at once, having a polycystic ovary. But as you'll see, this is not actually necessary for a diagnosis of PCOS to occur. So I decided not to cover that in my project. It's a pretty simple mechanism. You can read about it in this paper that I have a citation for on my wiki. But I decided that what was more interesting and would be a lot better to present on would be the manner in which the androgens come into play and how they wind up going into excess. So you'll see here's a sort of image of these many cysts. It's when too many eggs develop in an ovary. Around them you have these theca cells, and the theca cells are recruited to the area within the ovary around a follicle that begins to mature. And what theca cells do is they produce androgens, and androgens are converted into estrogens by nearby cells in the ovary called granulosa. And this allows the follicle to grow. So what happens in PCOS, partially, is that the theca cells are hyperactive and you develop too many androgens. So I want to figure out why that happens, and probably there are many different factors in this. So one of the most important factors in PCOS, as far as we can tell today, is the presence of insulin resistance. And insulin resistance is intrinsic in PCOS. And what this means is that it is something that someone is born with that we aren't necessarily sure why, but there are probably a lot of different reasons why that happens. And as we know from our module on diabetes, insulin resistance is strongly correlated with obesity. And what we saw in our articles and videos was that it's not clear whether that's insulin resistance leading to obesity or obesity leading to insulin resistance. It's been assumed for many years that the correlation goes obesity causing insulin resistance, but recent evidence is suggesting that it's the other way around. And of course, intrinsic insulin resistance is something that we think more about with diabetes type 1, whereas obesity is something that we think about more with diabetes type 2. So these are some interesting sort of parallels to our class. But it is a unique feature to PCOS, the manner in which the insulin resistance occurs. So something that we know about insulin resistance is that in PCOS, hyperinsulinemia, which means high levels of insulin in the serum, which is a symptom of insulin resistance, is correlated, so there's my directional sort of correlation, with hyperandrogenism. So the collective symptoms of high androgen levels are known as hyperandrogenism. That's what I was talking about with hirsutism, acne, that sort of thing. So what that means is as insulin levels increase, insulin levels being a symptom of insulin resistance, androgen levels increase. And as insulin levels decrease, androgen levels also decrease. But androgen levels do not have an effect on insulin levels. So if you flip these words, the correlation doesn't hold. So that's kind of interesting to me. Like, to me, this says that the insulin resistance is primary and it results in changes in androgen levels, but more research is needed on this front to determine how and why. You'll see with the rest of my presentation that there are some ideas as to how this happens, but we're just beginning to understand it. So research really needs to continue in this area so we understand better how the insulin resistance in polycystic ovarian syndrome happens and how it creates this issue with obesity. You can read a little more about how the insulin resistance presents in PCOS in my pathogenesis section. So we're going to move on to another manner in which hyperandrogenism can develop. And so sort of a basic underlying theory in PCOS is that there's some sort of genetic defect in the steroidogenesis, which is the production, the genesis of steroids, within those theca cells, these guys that we mentioned before. So there's several different enzymes and hormones and all sorts of stuff here. So you can see that the theory says that there's a few different enzymatic processes that may be genetically altered in someone with polycystic ovarian syndrome relative to someone without. So in the process of converting cholesterol to androgens and other steroids that are necessary for normal ovarian function, these enzymes are sort of hyperactive in polycystic ovarian syndrome. So you have cholesterol getting converted to pregnenolone, and then that pregnenolone is hydroxylated by this enzymatic process, and you get DHEA, which some of you may have heard of. And DHEA is then transformed into these active forms of steroids that the ovary can actually use. At the same time, progesterone turns into androstenedione, so that's something else going on, where you can see we're getting into a more androgen territory, right? So this is a production of one of the androgens. Androgen is a very general term, and this is just one. Androstenedione is one of the androgens that we're talking about. In polycystic ovarian syndrome, this enzyme that creates this androgen, its function is increased 2 to 3 times. So you're getting way too many androgens just in this one step. So next you can see gonadotropins, which is, this is how the hypothalamic and pituitary axis impact the development of androgens in the ovary directly. So luteinizing hormone, LH, is something that we've learned about a little bit in our physiology class as well as in pathophysiology, and it's an important part of ovulation. Again, if you want to learn more about the process of ovulation, specifically in PCOS, you can read about that in Dunave 1997. She's got a really great article that I learned a lot from, and if anybody has more questions, they can look at that. So what's really interesting to me about this step in the process, luteinizing hormone is an essential part of ovulation, which in women with PCOS causes enhanced androgen synthesis in those theca cells. And as a result, in PCOS specifically, because the androgens are so high, it impairs the feedback to luteinizing hormone, because this doesn't get turned into estrogen, it remains an androgen, and luteinizing hormone continues to stimulate androgen synthesis. So there's something going on in this feedback within the hypothalamic pituitary axis that is very abnormal in women with polycystic ovarian syndrome. So here, these negative feedback loops, this calls us all the way back to our first physiology class when we talked about positive and negative feedback loops. So you can read up about that in Merab's text if you are curious about that and still wondering how that works. But this is a very clear example of that. And one that's very directly linked to the organ system in question here, which is the ovaries within the endocrine system. And something else that's kind of interesting here is that there's sort of a combined effect of insulin and luteinizing hormone, so remember we have an increased presence of insulin. Because there's insulin resistance, it takes more insulin to get the job done, so insulin levels are higher. And that combined with these higher levels of luteinizing hormone, we're not necessarily sure how they wound up that way in the first place. Maybe it was that the androgens caused them to be higher, or maybe it was that they were higher for some genetic reason. This is a step in the process that still needs a lot more research. But for whatever reason, maybe both, luteinizing hormone is higher as well. So you have higher insulin and higher luteinizing hormone, and that produces even more androgens separately from this process even. And so basically that the process by which insulin increases the presence of androgens seems to be related to luteinizing hormone. This is some separate research that DNF calls out to, but I'm not really sure how that works, and she doesn't really go into it, so maybe the research doesn't even know. Finally, although probably not really finally, another sort of possible mechanism for the presence of androgens has less to do with the ovary and more to do with the adrenal glands. So because this hormone that we talked about back here, this hormone process, this enzyme, actually it's a genetic enzyme deficit, actually it's an excess, genetic enzyme excess, CYP17A1, since this is upregulated, it leads to less feedback suppression of this ACTH hormone, adrenocorticotropic hormone. And that sort of decrease of suppression, that it winds up being an excess of ACTH, activates the hypothalamic pituitary axis. So here we are with our pituitary axis, again, hypothalamic pituitary axis. And the adrenals, because of that, produce androgens themselves. The adrenals produce them, not just the ovary, but the adrenals as well. And something that's interesting in here is that high level of ACTH, because it's not being suppressed, that's what that means, so it's a higher level, may be partially because of insulin resistance, although the steps are not yet clear, and we need to do more research on that as a whole within the field. So there you have it. There's many steps here, and this is just the surface into why polycystic ovarian syndrome may occur with hyperandrogenism. Why does hyperandrogenism form in women with PCOS? So there's some very general information for you. I hope you enjoyed.